everybody. Let me talk in this video about one of most interesting searching algorithm. Name it binary search. So what do you mean binary search and how it's work? First of all, to get started with binary search, your data have to be sorted. So if I have, like, for example, number of data, for example, I have 1, 5, 10, 13, 16, 20, 30. So this data, if you see it, it's sorted. So the data have to be sorted when you work with a binary tree. So if it's not sorted, with binary search. So if the data is not sorted, you could not use binary search. If you try to think about this sorted data and you are looking for number, for example, I'm searching for number 20. So is it necessary for you to go element by element looking for 20? Let me think about how binary search work. So binary search say, okay, instead of going one element by element and your data is the sorting, let me define the array from the middle. That means they find the mid element in the array. That mid element occur low plus high minus low over 2. This one, if we count the index, 0, 1, 2, 3, 4, 5, 6. So the low one is 0. This is low and this is high. Okay? So now let me first start. What's the low element? 0. What's the high element? 6. Minus 0 over 2. How much the mid? 6 over 2? 3. So now they take 3. Let's suppose this name of array is A. So he will take A for 3. How much A for 3? 13. He say, okay, if the number I'm searching for it greater than 13 or the number that I'm searching for is less than 13. If you look through it, the number you are searching for is 20. So 20 is greater than 13. If the number greater than the mid, just go look for the value that above it. So just look in this side. That means, okay, I'm sure my number is greater than 13 and the data is ordered. Why I have to go to this side? I know already my number is not in this side. So this is the basic interesting of it. So you are looking for the data above it. That means the low will be here. So this will be low and that continue high. So in real example, you say, okay, the low will be, in this case, if you have this case, low will be mid plus 1. Okay, and in this case, the high will be mid minus 1, and you will see it in different story. So you find this number. So now I have low and high. So let me calculate a new mid. So how you find the mid now? You say, okay, I have the low is 4 plus the high is 6 minus 4 over 2. 6 minus 4 is 2. 2 over 2 is 1. So 4 plus 1, 5. So now you are looking for the element A for 5. How much A for 5? Is it 20? Okay? That is is the number that you are searching for it less than or greater than 20? So let me just change this 13 and 15. I'm looking for 20 and less than 20. Is your number greater than or less than? Your number is not greater than and not less than. Your number is 20. That means yes, you find the number. So how did you see how you find it? You just find the number after 2 try. While in the normal way, in the linear, you will find the number 1, 2, 3, 4, 5, 6 try. So the linear search you find it after 6 try, but in the binary search you will find it after 2 try. Let me take another number for searching, so just to make you understand how this one work with different scenario. Let's suppose you are looking for number 2. That means 10. So you are search for 10. Okay. So first of all, where is the low and where is the high? You still have it. This low, this low, this high. Now you will look for the mid. So how you find the mid? If you think about it, you have the low 0 plus high 6 minus 0 over 2. The mid is 3. So you are looking for A over 3. Which is the number in A over 3? I'm sure you know it. The number in A over 3 is 13. Is that right? Yes. Is that right? Yes, 13. So yes, is the number that you are looking for greater than 13 or less than 13? You are looking for 10. 10 is less than 13. That means the high will be changed to mid minus 1. So the high will be here. So here is the high. Okay, because the mid is 3, mid minus 1 will be here. So now you are searching only in this part. So why you search in this part? And you already know your number is not here. So you just half your testing to middle. Say, okay, my number is here. So now let me do another test for the number. You say, okay, what I have now, I have the lower will be 0 plus 2 minus 0 over 2. How much the mid is 1. So what we are looking for? We look for a over 1. How much the a over 1 is 5. Is that right? Yes. So you say, okay, let me suppose it. I'm looking for, is the 5, is that my number is greater or less than 5? My number is 10, so it is greater than 5. So the low will be mid plus 1. Is that right? So that means this is my low will be. This is low. They refer to same element now. So now that we do another search, how much you have the low is 2 plus how much you have the high, 2 minus 2 over 2. Is that right? This will be 0 and the mid will be 2. So a for 2, how much a for 2? A for 2 is 10. Is the number that I'm searching for less than 10? No. Is it greater than 10? No. My number that I'm searching for is it 10. So yes, this is the number. I find it. So did you see how this algorithm works? He reduced the searching space to middle. So instead searching of like take n time, you take middle time. When we talk about the complexity of this algorithm, we would say the complexity will be log n. So now you will say with yourself, why log n? First of all, what you think? What is the search? First thing, you reduce to the middle. Second thing, to the middle. So now, for example, if you search for in 4 elements, second time you will search in 2 elements. Third time you'll search in 1 element. Is that right? Yes, that's right. Because this is how this algorithm works. Whenever you see this case, you would say this one take log n. But wait a minute, why you say this one take log n? I will tell you in the math. If you don't remember or you forget it. What you have in the math, you have y equal x over n. That means if y equal x will be 2 over 3, so how much y will be? 8. If you want to convert this to the logarithm, what you would say? You say n equal log x over y. So what y mean for you here? The number of something get doubled or number of something divided to mid. So now when we say log n, that's we mean something get double or something get divided by middle. So if you have this tree, for example, have 1, 2, 3, 3, 4, this 2, 4, 5, 6. 6 element. Second time it will be 3 element. Third time it will be, for example, 1 element. So some 6, then it be 3, then 3 be 1. So if you see, I don't see 6, 3, 1 is not good example. So that we suppose it be 8, so it will be more clear. So 8 be 4, 4 be 2, and 2 be 1. If you see, you are going to middle. First thing you have 8, then you have 4, you have 3, you have 2, you have 1. When see this case, same of this one. Something get reduced to mid. So this one take log n because something get reduced to n. Something if you go to the opposite side, if you go from this side, you would say, okay, I have 1, the 1 be 2, and 2 be 4, and 4 be 8. So something get doubled. So this one take log n. Okay? So for that reason we name it log n. If we see the binary tree, you don't understand what I mean binary tree, but just think about it just node. If you see this node, okay, What do you think about this node? How much time it would take? You have 1, then you have 2, then you have 4. Something get doubled. So this one means log n. So just put in your mind, when you have anything get double or get reduced to mid, you will say this one take log n. For that reason, you say, okay, this algorithm take log n. So if you compare linear with binary search, there is different, because binary search take log n while linear take n. So we reduce the search space. Instead having this time, we had this time with same data. So here we done, and thank you for watching, and see you.